Hi, I'm Nikki from educatingnow.com. Thank you for joining me while we look at a game called High-Low. And this is a game that's very versatile. You can use it for addition, subtraction, and multiplication. And it simply helps students to practice their strategies for basic facts. Here's how you play. Okay, so for high-low, what you're going to need as far as equipment is 10 frames are really useful for most students and 20 counters to use for their frames. You'll also need a regular deck of cards. It doesn't even matter if it's a proper full deck, and you're going to need one die. So how this game works is for the addition version, and I'll tell you the different variations after, but for the basic fact addition version, each student will flip over, they each get half the pile of cards, and they each flip over 2 cards. So I got a 6 and a 7, which means it's my job to add those. And what we're trying to do here is to move students away from finger counting. Once they're in grades 3 and above, we want them to be using what we call additive strategies. So for this question, one strategy is make 10. So what that looks like is if we had our 2 sets of numbers set up here, so there's my 6 and there's my 7, and it doesn't matter which way the students want to go, it's entirely up to them, but make 10 means that they'll move the counters to make one full 10 frame. That way they're left with adding 10 plus a single digit number, which is usually easier for most of our brains. So I'm simply going to move these 4 up to make 10, and I'm left with 10 plus 3, which makes 13. So essentially what I did was I took 4 from my 7, I added to the 6 because I know that 6 plus 4 makes 10, and then I added my remaining 3. Now another strategy for this one could also be near doubles. 6 and 7 are almost the same number, as you can see here. So some students like to think about this as 6 plus 6 plus 1 more. So 6 and 6 makes 12 plus 1 more. It will entirely depend on the previous knowledge that the students have. And what we want to do is build on what they have so they're not counting by ones, but using some sort of additive strategy, which again means either doubles, near doubles, or adding by making 10. So I have a total of 13. My partner has 4 plus 7. So
I would take 3 from my 4 to make 10, add 1 more, that is 11.
Now to see who wins the points, we're going to use our die. If you roll it and the number is odd, the person with the low score wins. If it's even, the person with the high score wins. So if I roll, I got a 6, my score is higher, so I would win the point. I will take those cards. And then we will continue to play. Now, when you encounter face cards, you have a choice. For beginner students, I allow them to use all the face cards as 10 because that might be a skill that they're really needing to practice, is adding other numbers just to 10. But if we're ready for more of a challenge, then the jack is equal to 11, the queen to 12, and the king to 13. And I always write that on the board so that they know. Aces are always 1. So we would continue to play, rolling our die to see who gets the cards, who wins the points. And again, if it's odd, the low score wins, and if it's an even number, the high score wins. The 10 frames are valuable for helping students to create those visual strategies. Once they've used this plenty of times, you will find that they no longer need it because they can just do the strategy mentally. Now, there are a couple of other variations. Once students have automaticity with their basic facts, we can move on to helping them to develop mental math skills with double-digit or triple-digit numbers. So in order to play the larger number addition version, you need to remove all of the 10 cards and all of the face cards from your deck. Once we've removed them, we're left with only single-digit cards, and I like to start by having my students add single digit to a double digit and then move on to adding 2 double digits. The way you play it is identical. You each, in this case, we won't need our 10 frames because we're going to be working with numbers that are beyond 10. So we simply have Each of us has our half a deck of cards. We flip over 2 cards to make a double-digit number. So my card, the way I'm seeing it, is 25. You're seeing the opposite to me, so you would see it as 52. It doesn't really matter as long as they have a double digit. So 25 plus 2. So that one wasn't too challenging, simply 27. But you could also add 2 double-digit numbers. You could add 25 plus 21. And what we're looking for is for students to be using partitioning strategies. So adding their 10s to 10s and 1s to 1s, or rounding the numbers, adding and then compensating. There's lots of really effective strategies. What we don't want, especially at this stage, is counting by ones 21 times. If students are doing that, then you need to revisit the previous version and make sure that they have automaticity with their basic facts. The game is played similarly in every other way. They would add their cards. So let's do a round here. So mine is 25 plus 21. So I have 46.
Got a little higher number. I have 85 plus 89.
So what would your strategy be for adding this one?
This one, I like to consider this one actually as 90 and then adding 85 on top of that. So 90 plus 80 makes 170. Plus 5 is 175. Because I've added one more to make that 90, I now have to take that away. So now I have 174.
Good. So I only have 46. My partner has 174. And now she wins those cards because she had the higher number. And notice that she used a great strategy where she changed 89 to 90 and then compensated at the end. So you can also play this exact same game for subtraction as well as multiplication. The rules all stay the same, and you can even use it for multiple digit multiplication by removing those 10 cards. So you could do things like 41 multiplied by 3, where students would then partition and do 3 groups of 40, which equals 120, plus 3 groups of 1, which is 3, so 123. And that way we can allow students to develop their mental math skills beyond the single digit numbers.